Hello everyone. In the last two classes, we had discussion on expression for length of belt in open belt drive and in cross belt drive. Today, let us take up one more derivation, that is derivation for ratio of belt tension. So we will see how this derivation goes on. Here actually we will derive that ratio of belt tension. We have the different tensions here, T1, T2, and we will derive the ratio for these two belt tension. For that, I have considered one pulley, and this pulley is driven pulley, or you can call it as a follower. And you can see that this is a follower which is rotating in the clockwise direction. So this arrow indicates the direction of rotation of this pulley, that is in the clockwise direction. And after that, I have you can see that I have mentioned two tensions here. One is tension T1 in the tight side, and this is tension T2 in the slack side. Along with that, I have represented many of these components. I will tell you later. One important component along with these two tension is this angle of contact theta. This is a tension T1 on tight side, tension T2 on slack side. This is theta, angle of contact between this belt and pulley. So these three are very important. Next, after that, so I have mentioned here clearly, figure shows a driven pulley rotating in the clockwise direction. And next, let us see which are all the important components of this derivation here. So for that, I have taken again T1 as a tension in the tight side that I have shown here, and T2 as a tension on the slack side I have shown here, and theta is the angle of contact between the pulley and the belt. Next, for that derivation, instead of considering this entire belt surface or in that entire contact area, I will consider a small element PQ. Yes, I will consider the small element PQ. That's what I have expressed here. Consider a small element PQ of the belt. Let delta theta be the angle subtended by the element PQ. So theta is the total angle subtended by this entire belt which is in contact with the pulley, whereas delta theta is the angle subtended by the small element PQ. Next, once you consider this, I will take that which is a tension on slack side for that element and which is a tension for tight side for that element I will consider. So T is a tension on the slack side. Here you can see T is the tension on the slack side for this element PQ, and T plus delta T is the tension on tight side for this element PQ. So that is what same thing I have written here. T be the tension on slack side, T plus delta T be the tension on tight side. Next, mu is the coefficient of friction between belt and pulley, and R is a normal reaction exerted by the pulley on the belt. Yes, this R is normal reaction exerted by this pulley on the belt. Next, F is equal to mu R be the frictional force acting perpendicular to the normal reaction. Yes, this frictional force F will be acting perpendicular to this normal reaction R. Next, this element PQ will be under equilibrium, or you can say it as this element, considered element PQ will be in equilibrium under the action of some forces, and we will see what are those forces which makes that element to PQ in equilibrium. So the slack side tension T acting at point P. Yes, this is this slack side tension T acting at point P, and tight side tension T plus delta T acting at point Q, and normal reaction force R, this is a normal reaction force R, and frictional force F. So under the application of all these forces, so this element PQ will be in the equilibrium. So these forces, due to the action of these forces T, T plus delta T, R, and this frictional force F, this element PQ will be in equilibrium. So next what we need to do is, we will resolve these forces, that is this tension T and this tension T plus delta T, into vertical and horizontal components. Let us see now. So resolving the forces horizontally. So this is the tension T which is acting at point P, that has to be resolved into horizontal and vertical components. This is that angle delta theta by 2. So this will become T cos delta theta by 2, and this will be T sin delta theta by 2. You can write this horizontal component here also, no problem. Similarly, here it is T plus delta T. Sorry, by mistake I have written it as delta theta. It should be T. Please make a note of change here. This is T plus delta T here. And here again this will be angle delta theta by 2. So this will be T plus delta T cos delta theta by 2. Similarly here, please make a change here. This is T plus delta T. So T plus delta T sine delta theta by 2. Please make a change here. It should be t plus delta t. Similarly, it is t plus delta t. That is tension on tight side tension acting at point Q. It is t plus delta t. So make a note, make a change here as well as here. It should be t in place of this theta here. And once you finish resolving these two forces, we will take that forces which are acting horizontally. That is resolving the forces horizontally. So first let us take all the horizontal forces. R is the one that is normal reaction force that I think you might have seen the previous diagram, that was acting towards right side. So I will take that normal reaction force R first. Next I will take the next horizontal force. This is T sine delta theta by 2 and it's moving towards left. So the sign will be negative. R minus T sine delta theta by 2. Again this horizontal force T plus delta T sine delta theta by 2. Again this is acting towards left side, so this sign again it is negative. T plus delta T sine delta theta by 2 is equal to 0. We will take it as in equilibrium, so we will equate that to 0. Next we will take these two to one side because the sign is negative, and R to one side as the sign is positive. So it will become T sine delta theta by 2 plus T plus delta T sine delta theta by 2 is equal to R. Next we all know that for small values of delta theta by 2, sin delta theta by 2 will be taken as delta theta by 2. I think in that previous derivation also we have made use of the same thing. Even you all know that we will make use of this thing in the mathematics. For small values of that alpha, sin alpha is equal to alpha. So for that we will substitute this thing here now. T instead of this sin delta theta by 2, for small values of this we will substitute this thing is that is delta theta by 2 plus T plus delta T, and this, instead of substituting this we will simply substitute this delta theta by 2 is equal to R. Next I will just simplify this. So we will write this thing as it is. Next I will multiply this T with this thing. So T delta theta by 2 plus delta T delta theta by 2 is equal to R. And these two are same, will get add up. It will become 2T delta theta by 2 plus again delta T delta theta by 2 is equal to R. So already we have taken this thing, that is delta theta by 2 as very small value. Here itself I have considered for small values of this delta theta by 2. So when this value is very small, so this product will also become very small there. So we will neglect this actually. So just since we have taken this as very small value, we have considered here. So when you take this as a small value, the product will be neglected because of we will get very small value there. Neglecting that delta theta by 2 because for small values of because for the small values of the delta theta by 2 we will neglect this product. Then it will be left with here this 2 and this 2 will get cancelled, and we will left with T delta theta is equal to R, and we will call this thing as equation number 1. And next, once you finish this, so let us move to the resolving of the forces vertical forces. So here actually we have taken this again this diagram and these result forces here. So first take this F is equal to, that is this is one vertical force, this one, and again we have one vertical force here and this one vertical force acting downward. We will take all these things. So first I will write this T cos delta theta by 2. Yes, T cos delta theta by 2, here it is acting in the upward direction, the sign is positive. Next this T plus, here again make a change here, it should be T plus del T, and here also it should be T plus del T here actually. So this is the force which is acting downward. Yes, I will write this force with a negative sign, that is T plus del T cos delta theta by 2. Sorry, not this force, this is the force which is acting vertically downward. Yes, I will write this force, this is the force which is acting vertically downward, T plus del T cos delta theta by 2 plus mu r, that is this frictional force F, it is acting upward, so sign will be positive. So this force is acting upward, so the sign is positive, and this force is acting downward, so the sign is negative. And whereas this force again it is acting upward, so the sign will be positive. Again we will take that we will separate these things, like, so this is negative sign, we will take to the other side, and these are in the positive sign will be in the same side actually. So T plus del T cos del theta by 2 is equal to T cos del theta by 2 plus mu r will be on the other side. Next again I will just multiply this with this term, T plus cos del T by 2 plus del theta by 2 plus delta theta into cos delta theta by 2. Next here on the RHS t cos delta theta by 2 plus mu r. So this t cos delta theta by 2 will get cancelled with the t cos delta theta by 2, which is on the LHS, and this is on RHS. So this thing will get cancelled. So we will be left with delta t cos delta theta by 2 is equal to mu r. Again, we will take this for small values of delta theta by 2. Cos delta theta by 2 is equal to 1. I think you all know that. So if you get this value as 1, so this will be left with delta theta, and if you multiply it by 1, it will be 1 delta theta only, is equal to, on RHS it is mu r. Just write this thing as it is. Then write the expression for that r. R is equal to delta t by mu, and we'll call this as equation number 2. So the first expression was, you can see there, it is r is equal to t delta theta, and the second expression is r is equal to delta t by mu. We will equate these two, equation number 1 and 2. This is t delta t is equal to delta t by mu, and one simple modification what we will do is, we will take this mu to this, that is the cross multiplication, and this t will come to denominator of this. So mu into delta theta is equal to delta t by t. Next what we will do is, very simple thing, we will just integrate that delta theta as well as that delta t. So we will integrate this between 0 to theta, and we will integrate this tension between t2 to t1. So if you integrate this, so we will write this expression, the same expression what we got here, we will write with the integration symbol along with the limits. The same expression I have written here. So if you integrate this 1 by t, you all know that log t, and if you apply that limit, it is upper limit by lower limit, or upper limit minus of lower limit. You can write it as log t1 by t2 there is equal to, and it is mu, and integration of this will be theta, and apply the limits theta minus of 0, it is theta, mu into theta. And if you remove this log here, it will become t1 by t2 is equal to e power mu theta. Yes, this is a expression for ratio of belt tension. It is very simple. First thing is, you practice the derivation once. Once you practice this, then definitely you can easily you can understand this derivation without any difficulties. I will recall this derivation once again. First we will consider a driven pulley, and the driven pulley, write the tension T1, T2 and all those things. Next, along with that, show the theta, that is angle of contact. Then after that, consider a small element PQ, and in that small element PQ, write that what is the tension acting at point P on the slack side, and what is the tension. Otherwise I will show you the diagram itself. I will show you the slide itself. Yes, here I consider a small element PQ, and once you consider this, so delta theta is the angle subtended by this element PQ. Then write which is the tension acting at point P towards slack side, and this is the tension acting at point Q in the tight side. Then after that, write mu is the coefficient of friction, R is the normal reaction, and F is frictional force. And then write that this element PQ is in equilibrium under the application of 4 forces. One is this tension T, and this tension T plus delta T, and this normal reaction R, and this frictional force F. Once you write this, then just very simple thing is resolving these tension, that is this T and this one T plus delta T, vertically and horizontally. Along with that, as we said already, it is in equilibrium, we will equate it to 0. So that is resolving the forces horizontally. So write all the horizontal forces, and please take care of the sign also. Next, after that, we will separate that, we will make that negative terms to come one side and positive term to come one side, then it will become positive on both the sides there. Then for small values of delta theta by 2, your sign delta theta by 2 is be delta theta by 2, write that. And here when you come to this step, this product will be neglected because this value we have taken it as very small. Then it will be this two will get cancelled here, we will be left with only this thing. We will call this as equation number 1. Again, we will take the forces which are acting vertically, and there also you just write all the forces which are acting in the vertical direction, and please take care of the sign properly. Then make that positive terms which are positive sign to one side, and term with a negative side to other side, thereby which it will become positive sign on both the sides of this equal, that is on RHS as well on LHS. Next, you simplify this. This term on LHS will get cancelled with this term on RHS, so we will be left with this term again. So for small values of this value, we all know that cos delta theta by 2 is equal to 1. 1 will multiply by this delta t, will get as delta t only is equal to mu r. Then r is equal to delta t by mu. Call this as equation number 2. in the first equation we got the delta value expression for r. Even the second expression we got the expression for r. We'll equate these two, and one small modification is we'll bring this t to the denominator of this, and mu will get multiplied with this, and then we will integrate this delta theta as well as this delta t. This will be integrated between 0 to theta, and this will be integrated between t2 to t1. And you can see here, after that integration we'll get an expression like this. In order to remove this log, I will write that t1 by t2 is equal to e power mu theta. A very simple derivation. If you know how to resolve that forces, that is tension vertically into vertical and horizontal component, then it's very easy. Along with that, don't forget to write that reaction force as well as that frictional force. If you remember that, then this derivation can be easily done without any hiccups. So that is regarding this derivation, that is ratio of belt tension. This is also one of the important derivation there, so don't neglect that. Practice this derivation too. Next, again we will have some small formula which are required to solve the numericals on this belt drives. So let us see this with some theory concepts which are required here. That is, first thing is angle of contact theta. So it is subtended by the angle at the center of the pulley when a belt makes contact with the surface of the pulley. So that is what I have shown in the previous diagram in the driven pulley. So when that belt makes that contact with that pulley surface, that angle subtended by that belt at the center of the pulley will be called as angle of contact theta. And this angle of contact theta will vary for open belt as well as for this cross belt. For this open belt, this theta with the suffix O there will be given as 180 minus 2 sine inverse of r1 minus r2 by c, and we'll just convert into radians, that is pi by 180 radians here. And for this cross belt drive, this angle of contact theta with the suffix c, that is for cross belt drive, is equal to 180 plus 2 sine inverse of r1 plus r2 by c. Everything is multiplied by pi by 180. So listen here, it is minus and minus in this case of open belt drive, and it is plus and plus in case of this cross belt drive. This is the only difference even in case of that angle of contact formula. So please remember this. These formula will be made use in solving the numericals. So this is for open belt drive and this is for cross belt drive. So we have one more formula, that is that power developed or power transmitted by belt drive, and the notation is P. The pulley rotates due to the difference in forces in the tight side and the slack side. You all know that pulley rotation will be taking place due to the difference in tension between the difference in forces in tight side and the slack side, and that force is given as, that force is equal to T1 minus of T2. That is tension in tight side and tension in slack side. They have clearly given here. T1 is tension in the tight side, that is expressed in terms of Newton, and T2 is the tension in the slack side, it is again in terms of Newton. So this difference in these two forces will make that pulley to rotate. So that force is given as F is equal to T1 minus of T2, and power transmitted is equal to F into velocity of the belt drive there, F into V. F value is T1 minus T2, that is difference in the tensions will gives you that force that causes the rotation of pulley, T1 minus T2 into V. And this is the formula for that power transmitted. So you all know that this is T1 minus T2, or these two units of these two is Newton, and this is meter per second, that is velocity of the belt drive meter per second. So that is Newton meter per second. Newton meter can be given as joule, that is joule per second, and joule per second can be called as watt. So that's why unit for this power transmitted is watt here. Power transmitted P will be given as T1 minus T2 into V. If you divide this by 1000, it will give in terms of kilowatt. And if you don't divide this by 1000, we'll be simply write it as T1 minus T2 into V in terms of watts. So this is the formula to calculate power transmission. So the numericals in this will be very simple. Maybe asked on that velocity ratio, or they may ask to calculate this power transmitted, angle of contact, all these things. Very simple thing. So we'll take up that numericals later. So remember these formulas which are very, very important. So I think this is enough for today's class.